The GHS is not accessible.
Okay.
Sure. Could be our capital.
Huh?
Could be our
Yeah, you know, trials sounds crazy. I just were looking for something.
We don't see this. I mean, this to try to like engage the team.
Yeah.
In providing feedback on the story. Okay. It's cute, right?
Wi-Fi. There.
Oh my goodness, Wi-Fi, crazy.
Is there anything you have to do to? Yeah, you do. Because all I have is that. That's gotta go inside the controller brackets. So the need to vote.
That's yours. Yeah. That's the one you want. That's the one you want. You know, clone the desktop or grab the URL.
So you put a bar button. But first you have to put a
Is that where you want to put it?
Oh, actually, no, we just put a spot in the navigation controller. So you just put a bar button there.
I got that too.
All right, we ready?
You know what?
Huh?
Who was it that you said I
You deleted the view. So you must have clicked on the white space.
So, when I embedded the navigation. Drag it on next.
All right, guys, let's get started.
Looking master man.
Do it. All right, cool. So last class we did a pretty in-depth class on view controllers and view hierarchy and how the object library works and properties and segues and relationships between views, right? Can someone give me a kind of a high-level description of how navigation controllers work?
Navigation controllers split across each top and bar on the same level that you're in the cards.
Mhm.
It gives you the back options as you continue progressing through your story.
Okay, yep, that's right. So visually, that's exactly right. So everything that falls under a navigation controller has a top bar and has a back button if you move forward in the stack, and then has the optional button on the right corner, right? And what's the button called in the right corner of the navigation controllers?
Bar button.
Bar button, right? How does, in terms of kind of theory and conceptually, how do navigation controllers work? Yeah,
I might be saying this wrong, but it's sort of like a stack hierarchy. So like each view falls on top of the stack, which allows you to go between the stacks. So if you want to go back, you just remove the top layer of the stack off and go back to the previous part.
That's right, exactly right, yeah. So so navigation controller is essentially like a deck of cards, right? The thing that's visible is at the top of the stack. Whenever we link to the top of the stack to do something, it moves to the top of the stack, and the other thing moves to the back of the stack. So going back basically just brings the other thing to the front, right? That makes sense? How do we insert navigation controllers into our workflow or into our view controllers? Yeah.
You can do it two ways. You can do it
using the editor once you selected any view controller, where you can do it in one of your tools. I forget. You can insert it as a view.
Exactly. Yeah.
Right.
Exactly. Drag and drop it from the object library, right? Yeah. How do we insert a different view controller in the navigation controller within an umbrella of navigation controller? So if I have two view controllers, I want something else to be in the navigation controller as well. How to do that?
Oh, embedded or.
So embedded is the first one, right?
Oh.
So how would I get the second view controller within my navigation controller? So if I have my nav controller here, right? And then I have my view controller, right? And then I have another view controller over here. How do I embed this into this as well?
Segue.
Yeah. So basically just a segue from here to here. And then this becomes, all of a sudden gets a bar automatically, right? Now, what's special about the segue? What kind of segue will this be? Show. Exactly, right? One thing to note with show segues, that I might have mentioned in passing last class, if you go to tutorials, some of them might be outdated. As of the past year, this show segue used to be called the push segue, but it's deprecated. Now it's called the show. So if I had another view controller here, and I had a button here, and I selected to show this modally, what would happen?
There would be no navigation controller.
Yeah. So semantically, why is it so?
That exists within the last name controller. So it's under the line.
Yeah. So it's basically kind of has a direct relationship just with this one, right? So it's kind of like a pop-up in the page. It belongs to this page, essentially. And we haven't learned, I know some of you did this part of your homework, but we haven't learned how to dismiss these yet. So that was a trick question. So what if I had this over here, this view controller display modelly, and I had a button here that says go back, and it linked to this right here? What would happen? Yeah, that's true.
Does it create like a new stack? Maybe.
Sort close, but not quite.
Show without the navigation controller.
Yeah, it shows a navigation controller because when you're linking from here to here, this is not part of the stack. Therefore, it loads this view controller outside the context of the stack, right? So it doesn't load the whole stack, it just loads this within its own context, which we don't want. Questions on these? Yeah.
One question. Once we try to segue an element into homework, Swift, Interface Builder does give you an option to push. It says push deprecated. Is it another kind of show?
It's exactly. It is a show. Some of their new APIs might not work with it when we get a bit more advanced. For right now, they'll work exactly the same. But when something's deprecated, Apple gives us like a year notice. So if they, for example, release Swift version 3 or Xcode 8 or 9, actually I think Xcode 8 is when it's going to happen, it will not work anymore, so the application will. So whenever a feature gets deprecated, you have usually about 1 year to roll out into new functionality. 1 or 2 years, depending on the magnitude of change. Any more questions? View controllers, segues, navigation controllers. Anything about properties that didn't make sense there?
I have a question about photos.
Yeah.
When you're putting photos in, do you need to be manually sizing them, or we still haven't learned how to size them?
Yeah, so we haven't really learned on sizing them because we haven't really worked with size classes yet, which we will do soon in the next few weeks. But basically with photos, one thing to keep in mind is photos always have an aspect ratio, right? So if you have a photo that's, let's say, 500 pixels by say 700 pixels. And then we have an image view that is, let's say, 700 by 200. There's a few ways to fit this in here, right? We can squish it, or we can either fit fire it, right? So our image containers should usually, it's one of the easiest integration, should be the same ratio as your photo size. So this should be, for example, 50 by 70. Then it will resize correctly. So that's all I'll say for now, because it gets pretty complex. But aspect ratios is the biggest telling factor there.
And then there's two places you can put the photo, and they both seem to work in Xcode. You can put them right into the folder,
Yep.
and you can put them into the images.xc assets.
Yep.
So does it matter where you put them?
Yeah, can someone tell me the difference?
No, I was asking the same thing because I put mine in the main folder.
Yeah.
And when I closed it out, the image got moved and it didn't populate back into the actual app.
So we'll do that. But can someone tell me the difference as to why you want one or the other?
Keep it a little bit cleaner if you put them in like the assets folder. And I think also you have the option like to copy it so that it stays such an image doesn't, so you don't lose your image.
Well, actually, both copy. You select the, remember, whenever you drag access to your projects, always select the copy asset.
I didn't get the copy option when I was putting it into the XC assets.
Yeah.
It might be that you might have clicked it once and it's defaulting to it. It should always ask for it. Although someone else said it last class. I don't know if Josh said that, yeah.
When I drag and drop, it gives you the option.
Well, it did that when I dragged and dropped into the main folder, but not the XC assets folder. And the XC assets gives you the option of the 1x, 2x, 3x.
Yeah. So that's the biggest thing there is when you drag into our Xcode image library, the XC assets folder essentially, automatically if we deploy our application to multiple font sizes, we upload different versions of our image. So when we deploy to higher density phones or devices, it automatically delivers the right image. Whereas if we only deploy from a group, it only deploys that across the board, which might be fine for your case, depending on the kind of image. If it's very rich images and your whole application is about content, then you probably want to deliver different sizes, different screens, depending on ratio, right?
And it's a performance issue if you're just delivering the highest ratio to all phones.
It's a bit of a performance issue. It's much more of a download issue. We don't want people who don't have to download large mega apps.
Got it.
Yeah.
Okay.
Cool. More questions?
Yeah, I'm getting a lot of errors. Just a statement cannot begin with a closure expression or unknown attribute interface. What are some of those? Because it's saying so many run fail.
I'll have to look at it. I mean, we can't debug before class. Yeah. Is that has? Oh, okay. What's the difference between storyboards and nibs?
Nibs you can only use once.
Yep.
And
Well, no, you can use it over and over again, right?
You can build
Single
multiple
story.
storyboards and have a lot
That's
of
what?
functionality.
That's what?
You can build a storyboard but have a lot of functionality.
I feel like a single existing view controller.
Yeah, so they're single existing view controller, so they don't exist in the context of the storyboard. A storyboard can call it. So if you have a screen that's always reused in your app, like a menu or even like a part of a screen, like for example, a footer, there might be a nib because it's going to be recalled throughout your application. What format? This is really won't help you much in development, but it's good to know. The underlying language behind our visual interface building components is built in what? XML. Yeah. So 3 ways we can build our views are nibs, storyboards, and we haven't done the 3rd one yet.
Objective-C?
Code, Swift, Objective-C. All right. So if you don't have any more questions, we'll jump on to today's lesson. So we started covering playgrounds. I really don't want to spend any time. I want us to start moving quickly so we can get to the fun stuff faster in the course. So can someone tell me what playgrounds are?
They're like little places where you can test small segments of code. It's basically just a less advanced version of your storyboards.
Exactly. Yeah. So they're kind of their file that has 2 main panels, right? What's the left panel? The code, and the right panel, the output, right? So they're super useful because before we had playgrounds, we had to run our application over and over again to be able to test things, right? So barrier to entry before was a big pain in the butt. Now learning Swift has become a lot more pleasant because we get instant feedback, right? And Xcode is very good at telling us what if something's the matter with our code. As we start getting into the actual Swift programming language today and over the next few months, you'll get lots of errors, but I don't want us to get discouraged by errors. Errors are usually a good thing, right? It's better to be told up front that something's the matter than find out later when your application runs and have to go through the debugging process, right? So I like to think of errors as kind of like helpful tips, right? Xcode gives lots of helpful tips. So if something from the very beginning doesn't work or is not structured correctly, we'll get feedback right away. To me, that's pretty invaluable. So today, I'd like us to move a bit faster, and I have some bonus items if we move by this quickly. Next class is when things start getting a lot more difficult with functions. But today, we'll go over the basics of Swift, meaning variable declaration, going over control flow, like conditional statements, loops, and just the very basic data types, and find out kind of a bit more about how Swift is built and kind of its base functionality in terms of its strictness and its dynamics. So I want to go over some basics, and I meant to do this over the weekend, but I didn't get a chance to find the book. There's a book for those of us who haven't programmed in the past. I really want us to get in the mentality of breaking down problems simply. That makes a huge difference, perhaps not today, perhaps not tomorrow, but by midterm time, you'll all have the knowledge of all these building blocks, but then how does everything connect in the overall architecture of applications, or how do we break things down in terms of hierarchy and content and really the makings of this separate blocks that we're learning today. How do you separate your functionality and kind of the semantics of the functionality? So source code, for those of us, it's good to kind of give a baseline of nomenclature here. Source code is essentially kind of the code of our applications, right? So we'll be jumping to source code today for our apps. Syntax is kind of the grammar of our applications. And going through our state of mind, it's super important to understand that while in the beginning, the first week of Swift, meaning this week, we're going to focus on each of the instructions for learning Swift, right? We're building kind of a cake example, cake being the app. Learning the instructions, following the instructions one by one is great, and it's super important to learn the basics of Swift. But again, going back to the whole mindset of how do these building blocks work together, right? It's kind of a creative process. So it's a bit different than cake in that there's a lot more blocks, and a lot of these blocks are going to be moving asynchronously, right, all at the same time. So how do we kind of maneuver and orchestrate all these different functionalities? Again, this is something that really comes with practice. So I want us to get a bit more familiar and think about, as we're progressing through learning all these different, all these different subject matters for Swift, to kind of think about our end goal and think about how you would break down functionality based on what we know now and based on what we know in the next class. It's important to always go through the exercise of breaking down a problem into these smaller problems, right? So we went over Swift playground. So let's go ahead and do some show and tell here. I want to load Xcode. And what are the two ways for me to load a new playground? File new playgrounds, and the other way is but if we can bring it in our project, right? So it can be a playground standing on its own, or we can bring it in our project. So whenever we're working on a project, I'd like to always have a playground in there to always test my code. Yeah.
When you're testing your code in the playground, so you just like cut and paste it into the real thing?
A lot of times. What Playgrounds does now, since version 2.0, is it lets us reference code outside of Playgrounds. So we don't have to cut and paste a whole lot of functionality for us to test one thing. Before, we had to paste all the context for that specific code. So now, yeah, we can reference other code. And then whenever someone's working at Playgrounds, we can paste it out there. So I'll create a new playground.
Actually, just a question real quick. When I in GitHub, when I pulled from the master, from the GA master, whatever, am I pulling somebody else's code? Because I see a picture of somebody here.
Yeah. So can you accidentally deploy it to the main repo? I had accidentally given you access to that. I'll walk to the other. But I fixed that. So if you now sync now, that should be fixed, and it should be the latest stuff I have on there. So yeah, that's a good point. Everybody, please sync up your Git for Mac. So we'll create a playground, and I'll call this intro to Swift. And you can save it wherever you like. Classwork is probably a good folder. Can everybody see this okay? Or should I move to white? Yeah.
If we just dim the lights in the front.
That's okay. I'll just go to white. It might be easier for everyone. So we'll go default.
Yes.
And then let's make it a little bit larger. Here we go. Can everyone see this okay? Okay, so let's start with some of the basics of Swift. So Swift, over a year old now, a year and a half. It's a statically typed language. Can anybody tell me what that means? Or a strongly typed language, sorry. Yeah.
Looks very much like human English.
It can. That's because of its interpreted part. I'll go over that in a second. But by default, not necessarily as much. It's definitely more pleasant to look at Objective-C, but it's got some nuances that, for example, Ruby doesn't, or JavaScript doesn't, or Python doesn't. So what does being strongly typed mean? So it means when I declare something, when I declare a variable, when I declare a data type, I have to tell it that this data type is a type of a number, or is a type of a string, or is a type of a boolean. I'll go over all those mean now. But we have to be explicit in our definitions of our content and data type within the language. So by default, it's strongly typed. However, we're not required to declare what that means. So it means that it's interpreted. So interpreted means that we don't tell it what those things we define are. It figures out by default, but it still sets it to those things. So we cannot change its type later. So we'll see what that means in a second. So Swift is also compiled. And what's the What's the thing that compiles it called? Compiler. And what's the compiler that we use? That's an L. LLVM, low-level virtual machine. It's just important to remember that if you see it in tutorials and focus theory. So it's a compiler that both C languages, Objective-C, and Swift use.
Is everybody comfortable with the weather? In the climate?
You would just fan.
It's a little chilly.
So Swift is strongly typed, means that we have to declare the type of values that we're working with. Or in its underpinnings, it knows it must have those declarations, but we don't have to be explicit, because if we don't tell what they are, it will make the assumption for us. Now, starting out, you might say, like, why the hell would I care about that? If it figures out that for me, why would I tell it that we want these types, right? And the reason for that is because it's kind of documentation for your code. If you have a code base that grows within thousands of lines of code, which you all will by the end of the class, it might sound daunting now, but it really isn't. It's you bring in libraries, you'll work on, a lot of the code will be like simple functionality. Documenting your types is super important when you go back and look at old code, and when you collaborate with others, which I hope a lot of you will for our projects coming down the line. So although we don't have to tell it the type that we're working with for our basic types, it's important that we do, because it's kind of a way of documentation and annotation for our code. Speaking of documentation and annotation, we have two ways of commenting our code, either the 2 forward slashes that you see over here, or we can do a forward slash, and that works for a single line. So we can do single line commenting with forward slashes, or we can do the /* and do multi-line. And whenever we're done commenting, do a star or slash again. It's very important to always document and comment your code. Super important. If not for others, for yourself.
What do you like to see as a rule of thumb? Do you want comments for function?
Definitely a comment for function. For variables, you don't have to unless there's something tricky going on. That's something that will come with more practice to figure out what to comment, and I'll do my best to comment everything we do in class, so I have an understanding of how we should comment your functionality. But it's a good question. Your classes should be commented. A lot of times, your data structure should be commented, and your function should be commented for sure.
Should it be in present tense or past tense?
Present tense, usually. Yeah. Unless you have historical comments.
Should locate in present tense, past tense.
The comments.
So that's something I don't quite understand yet, is to your comments.
Oh yeah, so so in terms of context, I understand what you're asking that. So because in Git, comments are things I did, whereas within your code, it's things your code does. Right?
So you said *// ?
So multi-line is /*, and this is a multi-line.
And you don't need the colon then for the multi-line.
Nope. And you don't need colon for this as well. I don't know why it's there. Cool. One thing to note here, I went over this last class, but the import UI kit, all this does is it brings in a library that Apple provides us, and UI kit is what gives us our actual physical objects and interface builder. So our views, our labels, our text boxes, our view controllers, those all come from UI kit. So by default, playgrounds have import UI kits in case we want to work with actual physical objects in here. We're definitely doing it today, but we'll get to doing it online. Because remember, we can create those views with code as well, right? Questions about playground layouts and comments so far?
Does the playground have to be within your hierarchy to actually reference like text box you create within the story? Like so, like you said, it references like your controllers. So
Yeah, it doesn't have to be in your project. It doesn't have to be a certain kind of hierarchy in terms of files. Yeah, that works with all classes in Swift. So whenever we're creating files in Swift, where they are in terms of folders and groups does not matter. Xcode knows that they're in your project altogether. So we don't have to say, for example, images / whatever, or classes / file. We just reference the file. So we'll start with the very basics of different types, right? So in our written language, we have statements, and statements in Swift are strings. So strings in Swift are either in double or single quotes. So if I do, this is a string. That's a string. So string is one of the types. The strings are statements, right? They're sentences, they're phrases, they're essentially content or values in our application. They're words, they're letters, right? So in our written spoken language, just like words, we also have numbers, right? And the default whole numbers in Swift are called integers. So integers are whole numbers. Now, one thing to note is there's a difference between this and this, right? This is a string, and all we can do with a string is really display or merge it, right? And this is a number, and numbers you can do functions on, you can do operations on, right? So you can add numbers, subtract numbers, well, everything we do with actual math, we have the power to do this with. But if you have a number that's in quotation marks, we cannot run any operations on it. There are ways to convert it to numbers, but I don't want to go over it today. So there will be times you have to do that because when someone, for example, you have a text box and you grab the value for your application and user types in the number in your text box, that comes back as a string. So we'll have to later convert it to number. But we're not going to do it just yet.
What if the text box is like a type number? So like you have a type of email types.
Yeah, I think always comes as a string.
Still a string.
Yeah. We also have, just like we have whole numbers, we also have decimal point numbers, right? So we can have 5.25 or 5, a whole bunch of numbers. So these in Swift have two names. They're either called floats or doubles. Does anybody play with these yet? Does anyone know the difference? Yeah.
Double holds twice the value, after the decimal values has a float.
Yeah, yeah, exactly right. So the default for those these types of integers, there is either integer with 32 bit specificity or 64-bit specificity. So the one that has the larger value is more precise, right? That's double. So we'll say decimal / fractions are known as floats and doubles. Doubles are more precise. So because doubles are more precise, when we don't give it a type, remember in Swift, we can give it a type, and you'll see what that means in a second. Swift, by default, defaults to a double or a float.
even when I that 5 right now is a double.
Even what?
So that 5 right now is an integer, is classified as a double.
No. So if it doesn't have a decimal, it's an integer. If it has a decimal, you don't tell it that it's a float. It reverts to a double by default. And then we'll say default is a double if type is not specified. All right. So the fourth type I want to cover today, and there's tons of them in Swift, and we can even create our own types, is a Boolean. Can anybody tell me what a Boolean is? True, false. So it's true, false values. So those we just say true or false, right? And we usually have those either for storing either binary values or for comparison purposes in our applications.
Ones and zeros represent true, false, or
No, not by default. To some extent, yes. But if I go down the rabbit hole now, it'll confuse you. I'll probably explain that once we go into classes a bit more. But the two can be interchangeable depending on functionality. But we'll say by default now they're not. Questions on this? So before we go to variables, actually let me put UIKit at the top here. Before going to variables, I want to do some operations. So in Swift, we have operators, just like with math. So we have plus, minus, modulus. So if you do 5 plus 5, 10, right? If we do 25 times, right? Now, if we do 34.5 times 10, so Swift is smart enough to know to merge floats and integers when doing operations. However, when comparing and when we work with functions that expect these types, that's when we have to be more strict. But when we're doing mathematical operations, we can mix doubles and floats and integers together. There's one operator I want us to remember for now, and that's the modulus operator. Can someone tell me what that is? Yes, Scott. Yeah, exactly. It gives you the value of remainder, right? So if I do 10 modulus 3, what's my answer? 1, right? Because 10 divided by 3 is 3 with a remainder of 1. So the modulus is the percentage sign. If I do 9 modulus 3, what's my 0? There's also a couple more I want to go over before going to variables. The first one is the bang operator. Can anyone tell me what that is? It's not. So it means the opposite or not, right? So if I do bang true, what's my answer? It's not true, so it's false. Bang false, it's true, right? So if I do bang true, see my answer over there becomes false. So
That's still considered an operator, the bang?
yeah, I think it is.
one question is there really a reason to be differentiating between doubles and floats, or is that something that carried over from what computers were slower and you need to make it correct?
Yeah, there is. There is. Doubles are more precise, therefore theoretically can take it from memory.
Just wondering if we still.
But it will. Yes, but it will not make a difference at all in your application. I mean, if you're worrying about memory that much, it does. However, it does matter in the opposite, where if you have very precise numbers, you shouldn't be going with floats. If you have numbers like, to the, I don't know, to the 30th degree, right, of decimals, then you should definitely be going with doubles. Whereas the other way around is not as important. It's a good question. There's a few other more operators I want to go over, but not quite yet. We'll go over those in control flow. So let's get started with our variables and constants. So what's a variable? It's just like an algebraic a variable from algebra, right? So someone want to? Yeah.
Value that can change.
Yeah. So it's a value that can change. We can reference the value for our application, right? So the way we do a variable in Swift is we started with the var keyword, and we'll say var name. Let's say 10. You can do yours, have yours be whatever you like. So a few things to note here. Number one, what kind of value is Teddy?
String.
It's a string, right? So we didn't have to tell Swift that this value, this variable is a string. Therefore, what was the nomenclature for that? When it's
Strongly typed.
yeah. So but what? So when it figures out what type of value it is by itself. Yeah, inferred. So because this is inferred to be a string, if I do name equals 5, Xcode will yell at us. It's thinking. Yeah, it's still thinking. When things are grayed out over here, it means that it's thinking. You'll probably notice this as our playgrounds get larger. Did you guys get an error? Mine is acting slow. Yeah. So if I do, however, name equals Ina's my dog, it doesn't give us an error, right? So when we first set a variable, and whether or not we tell it the type gets set. So we cannot change the type. We cannot redeclare the variable with a different type. However, we can redeclare a variable with the same type. So the same thing happens if I have var num equals 5, then num equals 10, num equals 5 like this. Or actually, I'll go back to my previous example, 5 in quotes. Give us the error, right? And again, in the beginning, this becomes a bit scary because we see red exclamation marks, right? But it's much better than being told upfront live rather than running our application and having it crash without feedback, right? So this feedback becomes super, super valuable. Now, when we see the little warning over here, you can click it and it'll tell you what the error is. Sometimes when it's a bit of when it's not a binary problem, like meaning that it should not be this way, Xcode does recommend fixes. We probably won't run into any of those today, I don't think.
You don't need a semicolon for anything to do with this fix.
You do, so I'll get to that right now. So I'll say num equals 10, right? So if we don't want Swift to infer that for us, so I'll say, add a comment here, it's an interpreted variable, string. Right. So if we want to tell Swift explicitly what kind of variable we're working with, we'll say variable, we'll say location, and we'll want our location to be a string. So the way we do that is after our variable name, we do a semicolon, bet your question, Santiago, and we say string.
Semicolon or colon?
Sorry, colon, thank you. Yeah. There's no, usually semicolons are in other languages like JavaScript, which means end of a statement in most programming languages. Swift, you don't need semicolons. It figures out by itself. So we'll say general assembly. just like with our number of life, will be an integer, which is int, let's say 42.
So anytime you want to define what the var is, use the colon.
Exactly, yeah. In our event, you almost always do this, unless it's something that's stupid easy. It's just good documentation for yourself. Yeah.
Is there a reason why you're capitalizing int and string, the s, and
Capitalizing on?
capitalizing the s and string and the I and n?
Yeah. So by default, everything in Swift is object-oriented. So everything is an object. And because everything is an object, we'll learn what it means later. The easy answer that we picked was because it's a class. Because everything Swift is a class. And classes by default starts with capital A.
Yeah, and then error message went up in the lowercase.
Yeah.
And also, does the var lock make it immutable and you be able to change that from general assembly to something else, or is it?
So because it's a variable, it's mutable,
Okay.
right? So we'll go into the immutable version in a second.
What is the so if the other one's interpreted integer or inferred integer?
Yep.
Then what is this called? Defined integer or?
This is just a typed variable.
Oh, okay. Yeah, lock isn't lock, it's location. Yeah, I thought it was saying like variable, like lock.
Oh yeah.
Okay,
Yeah, location. Yeah, so it's confusing.
Sorry, what was
There's
that?
an advantage of typing something over conversion.
The advantage? Yeah, the advantage is just annotation for yourself, documentation for yourself. When our programs get more complex, we'll be building our own types. So classes are types, view controllers are classes, view controller types. So when you have a whole bunch of types floating on your application, you want to be able to quickly figure out what it is. That's not to say that it'll take you any more than like 10 seconds to figure it out. But when you're going through a lot of code, it just makes a little difference when you know right away what it is.
Also, if we would if there's a restaurant called 55, you would want to define that it's a string.
Yeah. Or what becomes a bit more, so over here it's very straightforward, right? Because it's a string, it saves a string in quotes, like why the hell would I even care? It's not pretty, right? But when we work with APIs, and we have APIs coming through, and we match variables to API variables, and we say, for example, var location, and say API variable this, we don't know what the variable is coming from the API unless we open the program or digest it, right? Whereas if we say, hey, this is a string, and the string equals this value from the API, we therefore know the value from the API is a string, right?
Why did they make Swift so that you don't have to declare it?
Sorry?
Why did they make it so you don't have to declare it?
I mean, it's more beginner friendly. It's prettier. For example, the legibility and the prettiness of the language makes a huge difference. The reason the Ruby language has exploded so much the past few years is because it's easy to read. I went through the phase up. I started with traditional computer science background where languages I worked with like Java and C, they all require you to set type. And I went to Ruby and I was like, this is fantastic, right? This is so easy to read. It saves me time from typing. But then my programs in Ruby got super large and I was inheriting people's codes. And when you have millions of lines of code, hundreds of lines of code, it becomes a problem later on. So coming to language first, it's much more pleasant to work without the types. But once your programs get larger or you're referencing legacy code, this makes it easier. As a beginner who's teaching yourself and you see colon with a whole bunch of stuff after it, or you just see this equals this, of course you're going to go to letter, right? But if you know what that means, if you have just invest a bit in the education, this makes more sense. You're annotating, documenting your code. One more thing I want us to focus here is this number of live variable over here. So this is called camel casing. Camel casing is where you start with a lowercase letter and then every new word starts with a capital case letter. This is the Apple kind of ecosystem's best practice. You'll see in other languages, you might have something like var number of life, like that. I think it's called snake casing. And actually, Ruby does a lot of snake casing, right, Lindsay? Yeah, it's all snake casing. JavaScript, it's a bit of both. It's mostly camel casing, and there is really no right or wrong way. But the Apple way is camel casing.
And my favorite of that is when you start with a lowercase letter, it's called
Headless camel case. Yeah. So, best practice for camel casing is when you have a variable, you start with lowercase. When we start having classes, it will be uppercase. Therefore, that's why that's how this works. Training here, right? Same thing with floats and doubles. So I can do var complex num, and I'll make this a float. 3.14. Or more complex num, a double 3.14. I'm so embarrassed. I used to know the pi up to like the 36 number, but I don't remember.
Get out. It's over.
Right. So whenever we go and become more precise, it's double, and by default, double is the default, right?
Is Swift is a language where white space matters?
So white space matters in terms of new lines, and up to one character. But anything larger than one character, so if I have something like var hello equals world, doesn't really matter. It only counts one space. So it matters for single spaces and for new lines. But anything more than a single space doesn't really matter. So I can have as many spaces as I want in the same line.
If I'm doing like concatenation, do I need to have a white space? Or if I'm doing some sort of mathematical operation, do I need to have a white space? Or can it all be without white spaces?
It could be without white spaces. I think. Yeah. Yeah, it could be without white spaces. Concatenation. We'll go over concatenation shortly, and we'll test it, but it could be without white spaces. Good question. So we have variables, and variables change, right? We can reset the value of a variable, right? The opposite of a variable is called a what? So constants don't change. So how do we define constants? That's the let keyword. So never changing equals 54. So now if I do never changing equals 35, it will yell at us because we defined it as a constant. Now, see, in certain cases, Xcode gives us these recommendations, right? So it knows that never changing was a constant, and it knows that for this to work, we have to change our constant to a variable, right? I would say that this is one of those cases where I probably, it's good that it yells at us, but I would not take its recommendation because there's a reason you might have picked a constant, right? So constants are when we have values for our data that we don't want to change later on, right? So absolute truths that will not change our application. So maybe application settings, right? One thing to note that's floating on the internet is Swift can also be a functional language. And the way functional languages work are everything in functional languages is immutable, means does not change. And rather than changing things, you duplicate them and set a new value into a new data type, right? So I don't want to go down the hole now. Maybe we could do a workshop like at the very end of class because it's a pretty complex subject that even most experienced object oriented programmers don't understand. But there's value in kind of bending your brain to think that way. So Swift, because of its ability to have constants and a few other things in the language, can be used in a functional way.
In Swift, are we going to be working with pointers?
Probably not. Probably not. And Swift does have the ability to do pointers, kind of, but not in the same way that other C languages do pointers.
But we will be working with Objective-C in Swift.
We will, yeah. Well, tying the libraries together, anyway. All right, questions so far? So if I have two values here, num and number of life, I can now add these, right? Number of life plus num.
Where do you define num?
I define num right here.
So num is an integer, and number of life is
Integer as well. Right. So they're both integers. One is inferred. One is explicitly typed. But they still work because they're both numbers, right?
Just like a tiny execution question where you're typing a string, it like automatically types the colon for you at the end. Is there a way for you to not type that?
We're typing a string, like
You have to press right to get the other side. Like, is there? So how did you get to the end there?
so. You can either press the right
Okay.
key or press quotation to complete it.
Okay, so you can't. Okay.
Or you can tab, yeah.
You can tab.
Yeah. So, well. Whenever Swift is Xcode is offering to autocomplete, and let's say it gives all these options, if you want to just escape that, you can just press escape. It'll leave you alone. Autocomplete's very useful though. I mean, you don't remember. Doesn't matter how long you've been working with Swift. There's no way you can. Well, yeah, it's limited, but if you don't use everything all the time, so you might forget a certain type. So autocomplete comes in very, very useful, especially as we start bringing in libraries. Autocomplete works with external libraries as well. So as soon as we include a library in our project, Xcode starts parsing it and offering us all the functionality in autocomplete. All right, questions so far? So again, constants are immutable because they can't change. Variables are mutable, right? When we actually work with code in our programs, in playgrounds, everything gives us an answer back. But when we're testing things and integrating our code with Interface Builder, we want to see the output of something. This is very, very common, right? So if a user types in something in the text box, types in something else in the other text box, you might want to see what the sum of those things are, or maybe how our current program is interpreting those. The way we do that is by doing print and then the value. So hello world, like so. If you see online tutorials, the old Swift way of doing it was print ln, which stands for print line. But as of Swift 2.0, it's just print. Now, one thing to note here is if you do hello world after the print, we'll see hello world with a \n. Can anybody tell me what that means? Yeah. Yeah, so it's a new line, right? So whenever we enter something into our programs, it by default defaults to a new line because it's kind of the functionality of pressing enter. Right? Whenever we enter a string into a text box, we usually press enter or like a button that tells it to end, but the end also usually is in the line. So if you don't want to display the \n in our output, we can just do print hello with no new line. And then at the end, we'll do comma. And we'll do Terminator 0.
Mine isn't doing that. Is that just settings that I have on my Xcode? Or?
Maybe you have an older Xcode. What's your Xcode? Is it 7?
Yeah, 6.4.
Yeah, that's why. So 6.4 is still Swift 1 point something. So you should, before, I don't think next class it'll get in the way, but I think after that it will. Actually, it might, but it won't be a big deal. So Terminator just means what we have at the end of our line after we print something, right? So because we have now 2 empty quotes, it gives us nothing, but I can have something else. I'll add something else at the end of the line. So remember this print functionality, this print function, because we'll be using it to debug our applications all the time. If you do any kind of JavaScript, it's the equivalent of console.log.
Is that a colon or semicolon?
It's a colon. Yeah. There's going to be very few instances where we use semicolons in Swift. It's usually going to be colon. Should I make this larger? Is this okay for everyone? The back, good. So next point I want to get through is concatenation. So we have strings, and we don't only ever want to display strings, right? So what if I have something that, if I have a variable for name, and this variable changes depending on the text box, right? So if I want to print hello with a person's name, and the name is a variable within a string, that's called concatenation, when we can add Swift functionality, Swift expressions within our strings. So that's a backslash parentheses, and then we can enter the variable in here, the operation. And then I'll do the Terminator. So name was Ina, therefore it says hello Ina, right? If I made name world, we'll say hello world, right? So our statement here changes based on the name variable. So it's called concatenation. To your question about whether white space matters there, I don't think so. Let's double check that though. It shouldn't. Yeah.
In the text it matters.
In the what?
Yeah.
Well, yeah, in the text it matters, yeah, but in the actual calculation does not. Because the text is just content, right? It doesn't care about the content. It's computed values that it cares about. Questions about the print statement or concatenation? So I can also do things like print example number, example sum, and then do 5 plus 5.
Your last parentheses.
Yes, thank you. Right. So anything that we have in our concatenation over there, becomes a computed expression. So you can have variables, you can have operations, you can have functions that all get executed inside here. One thing you might also see is interpolation. So interpolation is where you merge two strings. So you can say hello plus world. Sorry, the other one is interpolation. The second one is concatenation.
Interpolation is math.
Huh?
Interpolation is math.
Interpolation is inserting a computed value inside a string, whereas concatenation is merging two things together. So you'll see that there's no space between hello and world, right? That's because we have two strings and no spaces, right? So if I wanted to have a space between hello world in our output, I either add it here or I add it up here.
So the one with the name, that's still interpolation?
Yes, exactly.
The one just above that?
Yep.
What program are you using to display this on the screen and zoom in and out really easily?
That's available through system settings, accessibility.
Okay.
If you guys, this is actually really useful. It's a Mac hack. So if you go to system preferences and accessibility, you can use this right here. So I hold on control and then just zoom in and out with a trackpad.
Does that actually happen on your personal screen as well? You actually?
Yeah, exactly. That's an exact mirror of what I have right now. Another thing you might see me bring up is, this is Alfred, but you also have the spotlight that comes with Mac. That's by default command space. And instead of going to applications and like searching for applications there, you can just type Xcode and it completes. Super useful. All right, questions so far? So our four value types that we've gone over so far are integers, booleans, floats, doubles, strings, 5. Yep. There's a whole bunch of more operators. This is available. I have it in the lessons folder. I don't want to go through everything right now. We'll get to these at some point, especially now when we go through control flow. But I don't want to cover everything one by one because we won't need to yet. So control flow. So right now we have a way of storing values in mutable or immutable ways, right? We know how to store different kinds of values, and we know we're getting a sense of how strict Swift may or may not be with our values, right? But now we have to get a bit past just data. We have to do things with our data, right? We have to make assumptions from our data, and we have to pass things around based on conditions, right? So control flow in programming is the process of conditionally checking things. So if something is true or false, then execute something. So if my name is Steady, then I will say I will print out Teddy works at GA, right? Or if my age is over 21, then I can print out you can trade. That's the first part of control flow. You can check statements conditionally, and it's all dependent on values, right? So we're comparing values against other values, right? So when we go through control flow of doing things conditionally, something runs if that statement is true, right? So if my name is Teddy, then do something, right? Or if my name is not Teddy, then do something, right? The second part of that is loops. So we can say, hey, if my name is Teddy and I'm guessing a number, I'm guessing I have 5 guesses and I've done 0 guesses, then I can keep checking for things, right? So the looping is checking for things until a condition is met. So they're both based on certain conditions, but one only executes once, which is the conditional statement, and a loop keeps executing until the condition is met, right? So they're both contingent upon conditions being met, but one just runs over and over until the condition becomes true. Yeah.
So I understand like loops and like control flow like in theory. So like in actuality, would a loop be used? Like say like you just join a social network, you don't have any friends. Is it a continuous loop saying scroll down until there are no more posts and you don't have any friends or something like that? It's like I don't understand how to really put it like in actuality.
Yeah. So we'll go to that. I mean, the easy answer is yes, but it's usually much more meta, much more micro than that. And we'll go over that right now. So let's start with the easiest one, which is just conditional statements, which is just checking 2 things against each other. So pretty much every programming language, I can't think of any programming languages that don't have control flow. Everything has conditional statements and loops. So this is a universal concept, just like variables is a universal concept. Constants is not available throughout all languages, but most C or object-oriented languages have constants as well. So let's give do we have an age value here? So we'll say variable age is 17 for now, and we'll change this soon. So let's do a little program that prints out certain things based on our age, right? So we'll say if, the conditional statements always start with if, age. So now we need to always compare our if statements with another value, right? So we'll say if age is less than 21, and after we do our check, our initial true-false check, we actually enter our code that will execute in brackets. So we start with an open curly bracket and a closed curly bracket. So everything in that is called the block, and this is the thing that will execute if our statement is true. So I'll do print, you cannot party. So this works great now, right? If I change this to 22, won't print anything, right? Our print statement, our print result goes away because this condition is not true, right? Age is 22, therefore 22 is not less than 21. So this never runs because this condition is not true, right? Does it make sense? So let's do another condition where we say else if age is larger than 21, saying you can good to go. So we can chain our conditions, our related conditions, by else, right? So the first part of the condition always starts with an if. Everything from that point on always goes to an else, right? Now let's make it a bit more exciting and say, hey, if our user is over 21, and if they are less than 55, then they can just party get in, right? But if they're over 21 and they are if they are over 21 and they are also happen to be older than 55 years old, like a senior citizen, they can get a discount on the booths, right? So we'll go with the condition of first saying, hey, if I'm 21 and I'm less than 55, we'll say you're part of the young crowd, right? So the way we can check two statements at once, so give kind of a starting place and an ending place for our condition, for our checks, is with a double ampersand. So this checks two statements. So I'll say else if age is larger than 21 and age is less than 55, you're good to go, but you get no discounts.
So there, the space matters.
Where is this?
If there's no space between age and
The greater than symbol or the less than symbol?
yeah.
Yes, it does. And you'll see why later because of closures.
Because of what?
Closures.
Clovers?
They're kind of anonymous functions.
CLOUVERS.
CLOSURES.
Closures.
Closures. So now we have two age brackets. We have less than 21, and we have between 21 and 55, right? So now let's do a condition for everything else. And what is everything else in this case?
Else. It's greater than 55.
Greater than 55, right?
Greater than.
So then we'll do else. You can party and you party on a discount. So now if I make my age 60, this third statement executes, right? So the everything else clause for our conditional statements is the else. It means that if our first few conditions don't meet, we have kind of a default, a catch-all for our statements. Now we can have as many else if statements as we want. We can have up to hundreds, but it's not good practice to have more than a few because things get very messy.
One question, Dave. Is it, you start your else next to the last bracket in that same line because of the practice, or does it matter if we started in a new line?
You practice, the best practice usually starts within the same line. You can start in the line, I believe, but practice there.
And what's the syntax for greater than or equal to?
Yeah, so then we have statements where if you are, let's say, we want to compare if something is not only larger than or not only smaller than, but starting with that number, right? So if you're 21 or older, right? We're going to say not larger than 21. So for that, you can kind of stack these operators. So you can say greater than or equal to 21.
And does the order matter?
It does. Yeah. So the equal comes after the initial operator.
I understand why the brackets and the parentheses are the way they are here.
Yep.
Is there, can you explain a general rule for when you have just regular brackets and when you have curly brackets?
Regular brackets being
Parentheses.
parentheses, yeah. So curly brackets are whenever you have a block. So whenever you have conditional statements or functions. So whenever something is true or you run something and you want to run a bunch of lines of code within that statement, that's when you have curly brackets. So over here, whenever something is true, we don't only need one answer, we can have multiple things happen. We can have, print hello world, and I'll make this age 53. So then both things here will run, right? So the brackets basically are used whenever we want to bunch a whole bunch of code together with a condition within a block of code. Parentheses are basically when you call functions. We haven't gone over functions yet, but kind of work in the same way, but it's only in one line. So curly brackets are whenever you are theoretically bunching a whole bunch of code together, a block of code. Now, we can have parentheses in our if statement here. So if we have a whole bunch of complex operations and we want to make our code more legible, we can actually do this. Right? Just like with math, parentheses are not always necessary. They're sometimes necessary. Same thing with if statements. We can include parentheses if you want to make things more legible and more organized. But if you're only checking against one thing, it's mere preference. I usually choose not to have parentheses there.
Does it execute these things in order?
It does. Yep.
So then we could just have the 55 and then put the over 21 at the bottom or something?
Yep. It'll execute the first thing only.
Okay.
So that's a great question. So everything that gets executed, everything that runs here, it will stop running something after something is true in our single block. So if you have a block with, let's say, 5 different if-else statements, once the first thing or second thing is true, it will not even check the other ones. That's actually an excellent question.
You know what? You're line 76 else, it's not showing
Any questions on condition statements? Does that make sense? So everything must start with an if. If we're checking different variations of our statement, we do else if. And then the catch-all for every other scenario is the else, right? And we don't need an else. We can have else. I don't know what to do. We don't need an else. We can have it so we check a whole bunch of things, and nothing might want to run. You might want to run nothing if those things don't come true, right? Are we ready for loops? Any questions on conditional statements?
Does print only work for strings?
So print expects a string, but you can have operations run within a string through interpolation. But print by default expects a string. So let's get started with loops, and we'll start doing some exercises. So loops are essentially they run over and over again until a condition is met, right? So let me go through an example here. Where's the remote control? Dang it. Well, both missing. My example was going to be that we have a remote projector, right?
Yeah.
And I press the up key, and it's okay, we're doing it. I press the up key, and this thing lifts up until it reaches the end, right? Same thing with down key. I press the down key, and let go, and this thing will slide down until it reaches the end, right? That's a loop. So it presses down, 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 down until the end is reached, right? So it knows that the end is reached because the end over here has some kind of numerical value, right? So Swift has a few variations of loops. We'll go through a couple today, and these are really the main ones you need to know. So the first one is a while loop. So with the while loop, we'll do two things. First thing is, let's do a variable called x, and we'll give it a value of 0. And we could say while x is less than 10, we can print running. It's going to print it infinite times. So let me actually press enter here. Make sure. So now, before you do anything else, below the print running, do x equals x plus 1. Can someone walk me through this? So we see that this logic here ran 10 times, right? What did it run 10 times?
The block of code where it tests to see if x is less than 10. So first it defines x as being 0, then it checks to see if x is less than 10. If it is less than 10, then it prints running. After that, it adds increments x by 1.
Yep.
And it keeps doing this until x is equal to 10.
Exactly. So does anyone understand why this piece of code is here? X equals x plus 1. Right? If we didn't have to do here x equals x plus 1, if we had this run print running just while x was less than 10, and we remove this over here, it'll just keep running infinitely because x would always be less than 10. Right? Yeah.
Let's say hypothetically we didn't put x is equal to x plus 1. And we did this because we want to have another function to be running asynchronously. And then it would make x is equal to being greater than or equal to 10 based on some other outside factor.
Sure.
Would this cause the application to crash?
That's a good question. The answer is not if you do it correctly. If your code is smart enough to if you pass things around correctly. But you have to have some kind of context of where you are here. You have to check against something. This enumeration over here does not need to happen here. You can pass this to another function, and that logic of how you count up can be dependent on probably something else. But the counting still needs to happen in some regard because this will only stop once the statement is true. Or false, rather, sorry. It will run while it's true, but stop while it's false.
Maybe this is like for a later lesson, but is there a time when, like the scenario that I just pointed out, is that a bad practice to do that? Is there like an alternative to doing that?
It's not a bad practice if you're clear in your directions. Clarity is a big one there. It's only bad practice if you're just like running a function that has an abstract name and does not have any comments. Then like if a user, brings up your code and like, what the heck is going on? How is this enumerating? Right. And we'll get to function in this class and I'll show you. We're going to do an example of that. But you do want to make it clear of how the comment is happening here. Even if it's not happening here, you want to comment how it's happening. So over here, basically we're saying, hey, we're running this thing 10 times, right? We're running 10 times because x factor is 0. So first time it's running, x is 0. So we're printing not running. Then the second thing that happens is we're saying the value of x equals the current value of x plus 1. So x equals 0 plus 1. So now x becomes 1. And we'll run this again because x is still less than 10. Same thing happens. Run again, print running, then we say x equals, at this point, x is 1, 1 plus 1. So now x becomes 2, right? Is x still less than 10? Yes. Run this again. Count up. Is x still less than 10? Yes, count up. So the code in while loops will run indefinitely until it gets falsified, until the statement that you're entering there is no longer true. So going this route, we need to always have this variable defined up front. So now, if I do a print x is 10, right? I'll make this, I see some folks squinting, that makes it a bit larger.
Yeah, it's funny, it's like two sides.
How did you just do that?
Xcode preferences, and then go to fonts and colors, and select presentation large. You can add your own color scheme as well. My favorite is Solarized Dark.
This is a weird question. You have it on Solarized Dark because you want the dark background with the light green. That's because there's strain on your eyes that's kind of
Yeah, for me anyway. It's preference. I feel like it's bare in your eyes.
How do we switch it to shows?
Yeah, so you go to Xcode and preferences and fonts and colors, and then just select something from here. And if you search for fonts and color schemes for Xcode online, there's tons of other ones. There's both Solarized Dark and Solarized Light. And they're a bit, they're a bit more neutral colors than just white with all these stronger colors.
If you're staring at the screen for a long time, is it healthier to have the colors?
I feel like it is, yeah. I run all my, my terminal, all my text editors in Solarized Dark. Questions so far on while loops or loops in general? So while loops, the block of code inside while loops will run as long as the statement is true. So over here, this is called enumeration, right? We're saying, hey, x, the value of x will be the current value of x plus 1. The other way of doing this is doing x plus plus. That means make the current value of x, make the value of x be the current value of x plus 1, count up plus 1. There's also minus minus. So if you're doing the opposite, so if you're saying if x is larger than 10, and you're starting at 20, same thing happens, right? Runs 10 times. Oh, that's right. And be careful with loops, guys, when you're testing stuff, because if you let a loop run enough in playgrounds, it'll crash your Xcode. Because it runs very quickly.
Is there a way to stop the execution with a keyboard shortcut or commands?
Not that I know of. You just command Q, get out of there.
but then you're gonna need to open it to edit it real quick, and then you're still gonna be
Usually it will be grayed out before it runs it, so you can just quickly scroll down and comment out. You can also quickly, so you can comment out the whole line by holding down command and do /. Comment out the whole thing. This is very useful. Or you can highlight a whole block of code and do command /, and it comments the whole thing out. So if it's running, you can just go into the while loop and do command /, and it breaks your code, so it stops running the loop. It's a good question. I don't know if I want to go down the rabbit hole yet. On the surface, it works the same way. I'd like for us to go over functions before going over that first. Just remind me towards the end of next class to explain that.
And what's the purpose of this?
What?
Because the last one was very clear, like what the purpose was, right? Like,
Yeah. So say you have a program that say we're breaking down the task of walking, right? So we can't say walk until you hit the wall or walk 20 steps because we don't know how many steps we're gonna do something. We say walk until you hit the wall, right? So when we don't have a clear end goal, we keep checking for things. Or if you have, for example, say an array, which we're gonna do next week, which is kind of like a notebook of content and variables, right? You keep checking everything in the notebook until you find something. So what I can do here is, say I'm gonna go back to x is 0. And say I want to, when I'm at 5, I want to print out you hit 5. So you could say if x equals 5, and the way we check an exact value is a double equals. And it's important to remember the difference between a single equal and double equal. A single equal sets the variable to something, sets the value to something. A double equal is used for comparison. The way I like to remember it, if it gets confusing for the first-time programmers, is a double equal is kind of like the seesaw, right? So you're comparing things.
I've seen in some tutorials that there's a triple equal.
Yeah, so certain languages, like JavaScript, triple equal is an exact match. In the context of Swift, double equal is the only one we need. But triple equal is if you want an undeniable, if you're checking the value versus checking an object. It's exactly the same thing, or if it's the same thing as a reference.
So it'd be like if I have one float and one double, when I try and compare them, they won't be equal.
Well, if the number's the same, it will be equal. So if x equals 5, print, we are at the 5th count. It's less than 10. That was running. All right. So basically what happens is runs once, says running, twice running, 3 times running, 4 times running, 5 times running, and prints this, right? Because our value of x is here. So when we want to check things and compare things, that's what loop's going to be very handy. You can force exit, yeah. So the exit keyword, I believe the break keyword also works. So,
wouldn't that actually be the 6th count?
yeah, so because it starts at 0, yeah, it'll be the 6th count. So the break keyword stops it from running. And we see that now x no longer equals 10 because we stopped it and we equal to 5. I think exit should also work. If you're mistaken though. No, just break.
do for return? Does return also do it? Or only for functions?
It should work in the context of return is for is the keyword is reserved for functions. It works in loops. The difference between doing break and return, break stops it, whereas I think return in loops, if it's in the context of something else, exits and returns a loop. But that should be in function anyway. So I will say returns is for functions. Theoretically, yes, you can use it in loops, but that rabbit hole is a bit deep as of right now anyway. Because return always returns from the thing that calls it, so you cannot call loops, right? You just execute loops in order, in procedural order. All right. Questions on while loops? Some good questions. So one thing to note is when we're running through loops, it's very useful to always be aware of where we are, right? So in this case, we have x that's being counted up, right? So we can always reference the value of x, therefore call x within the loop itself, right? So it's useful because while we're running a loop, we need to know where we are, where we're counting up, right? So just to make that point, we'll say counting number x, right? So the last value is counting number 5. So for loops work in a similar way in that we need a start and an endpoint, right? And the thing that runs in for loops is runs as long as the loop is true, right? So the takeaway here for control flow statements like conditionals and loops is it runs the block of code as long as the statement is true. So the way for loops work are we give it a temporary value. We don't have to say, we certainly can, but we don't have to give it an x, for example. So I can say for I, and then we follow that with n. And the I can be whatever value you set it. So this is essentially a temporary variable that's available to us in the context of the loop. So let's say 1 to 5. And I'll say we're counting I.
Doesn't the playground won't show we're counting 1 or counting 2?
It should. I'm not sure. I haven't tested since the last one. I'm not sure why it's not showing. It used to show all of them running in order. I'm not sure why it's not showing it now.
What if you define I outside of the scope of the form?
So if you have var like this,
That var I is equal to 3.
then you wouldn't need a for loop, right? But what you can do is you can do var x equals 5, and you can do from 1 to 5 like that. Does that make sense? Because it's 3 periods.
So basically, the way a for loop is structured is for variable is equal to for variable for some variable in and then
between two numbers.
Number and 3 dots and then another number.
So the 3 dots it's conditional. I'll go over it in a second. But as of right now, yes. So I is our temporary place in our counting up, right? So if we say our loop starts from 1 and it counts up to x2, which is 5, right? I becomes starts at 1 and it counts up from that point on.
Why did you change it from x to x2? I mean, because I know that you have x up there in line 81 defined as 0, but it's a variable. Is there a problem when it was just x?
Yeah, you can't redeclare variable.
I can declare a variable, yeah. I can set
So
x.
if you just said x
Yeah, I can
equals
set x equal 5, yeah.
Stop
It might just restarted. Something cute. You can do a force quit. So let's give it, I'll do another one proof point here, y equals 0. So between y and x, right? So for loops work in the way that we can count between 2 variables, 2 numbers, and it could either be variables that we're bringing in, or it could be numbers, and then our I value here takes the position of our counter. And then I doesn't have to be an I, that could be anything we set it to. It's a temporary variable that's only available to us inside this block over here. So I can say for O, for example, same thing. So it's the same thing as saying for var O equals x, and then it counts up. So for O and y to x.
It always starts with 1.
It always starts with the first value, right?
Wait, so you cannot do what you did a second ago? You said for var O is equal to.
No, this is just this. That's what that means essentially. It's setting O to be a new variable that's for use only in this context, only in the for loop context.
Okay. We'll count down and flip from y from x to y.
You know what?
We'll count down if you go the opposite way, like if it was x to y.
No, you can flip them.
What's is scope out of the context of this lesson?
Yes. That'll come next class. I'll start the next class. But to answer your question, the O is only available in this scope over here.
So, sorry, so the 4.
Yeah.
I'll just
No, it's okay. Let's talk through it. So we're saying, so the for basically starts a new loop, and we're saying, hey, for O, which is our temporary variable while we're counting up, right? And we're saying O will be the first value that we're counting up from, right? And O will be the value that we enumerate on top of. So our O value is kind of our place in the loop, right, as we're counting up. So every time we run the loop, O changes based on where we are in the counting. Does that make sense so far?
Okay.
And then we're saying for O is where we are between these 2 values. First value being the starting value, second value being where it ends.
Yes.
So first value, then it starts counting up by 1 as we're going through the loop. Yeah.
You say the for loop is a special case of the while where you have to move the count at the end in the while.
You don't have to do the count because the for loop is automatically here yet. Now, there's a slightly different variation of this as we're going through data, but we use the for loop all the time when counting, when enumerating through large data values.
The for loop enumerates, whereas the while loop you have to choose how to go.
Yeah.
By 2
Now, the 3 dots means that it will always count between 0 and 5, and it will stop at the actual 5. We can actually have it stop right before the 5. So we could say, hey, we would count between 0 and don't include the 5th counter. So the way we do that is instead of having 3 dots, we have 2 dots and the less.
If you did greater than, would it do 7 times?
Let's see.
So it's just an error.
Yeah, just an error. Because when you're counting, why would you want to go greater than, right? You always want to either stop there or stop right before.
Could you do a mathematical thing? Could you do for y dot 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 x plus 2?
I don't think so, unless you do this, I believe. Yeah. Whereas if you just do, I don't know if that'll work, to be honest. Yeah, it works, but the question is, why would you want it to work, right? You want to find those boundaries before, rather than do a whole bunch of complex calculations here. In for loops, you want to keep them very verbose and very straightforward. So just because you can doesn't mean you should.
Right. But just get to know in case.
So that less than operator is taking effect of one of the dots.
Sorry?
The less than right there is taking effect of one of the dots.
Yeah.
Okay.
So basically it's saying, hey, count 0, count 1, count 2, count 3, count
Okay.
4, but don't count on the 5th one. Stop right before you hit the 5th one. Whereas the 3 dots, you count one more time on the very last integer, the very last number. So the 3 dots are called the range operator, and then the 2 dots with the caret sign, that caret sign means they are the open range operator. Questions? So let's do an exercise, and then I'm sure there'll be questions. 2 notes. Make sure you pull code from GitHub. And I'm going to try from this point on to have a cheat sheet for everything, for every lesson. So let's see here. GitHub profile. Teddy. 4. Oh, I don't want Teddy, I want GA students. Okay, so if you go in lesson 3, there's the slides, which we have for all lessons so far. The in-class activity is in the form of a playground. So when you work on this, please make sure you don't just open it. You copy it from the folder to your classwork folder. Otherwise, there will be merge conflicts if you're working it straight from here. Because remember, this is the same file as the one I'm pushing. So if you're working it here, there will be conflicts. You'll have changed what I have on there. So copy the playground file to your classwork or coursework folder, and then open it. Number 2 is there's this folder here, which is Intro to Swift. And I will shoot to have cheat sheets for every coding class we have from this point on. So you can reference this. It doesn't look as pretty here. Let me open it up. So this is essentially a cheat sheet of everything we've done today. Find. So I'll shoot to have this on every class that we do code in.
So for this exercise, we sync first, then we copy the folder to our
Do your classwork, exactly. So if you open up the exercise, so remember, copy this, and we'll copy it to my desktop. I might have worked on the actual file, but you guys should have a fresh copy, so don't worry about that. So if you open on the playground file, you'll see all the instructions and comments. I might have, shoot. There we go, okay. I knew it was going crazy. So feel free to team up for this. There's also a couple bonuses. And this Fibonacci sequence bonus will be available for the next 3 classes in different formats. So we'll be working on this quite a bit.
You said that you were going to be recording all your classes and putting them somewhere?
Yep.
Where are they?
So it's recorded. I posted a link on this recording on the lesson 2 or week 2 chat room. But if you guys want to subscribe, it's in Slack. If you guys want to subscribe, let me put up the YouTube channel. So there will be, it should be over here from this point on. Now it won't show today's lesson in the YouTube channel until it's over, but you can, if you ever miss a class, I'll post the live recording as we're doing class, and you can enter it from here straight.
So if we're not there, we can see it live.
Huh?
If we're not in class, we can see it live.
You can see it live, yeah, exactly. I think Cindy's actually seeing it live right now. She's homesick. Hi, Cindy.
And it records audio and
yeah,
and whatever's on the screen.
Now, one thing it doesn't record is the whiteboard. So as things get more complex, I'm going to be using the whiteboard a lot more. So just as courtesy and self notes, take a picture and post in the Slack channel. It'll be useful.
You said just copy the playground.
Huh?
Just copy the playground.
Just playground, yeah.
So for the GitHub challenge, we provide myself.
Yeah.
Sorry.
That's okay. Do you want to take a seat back there?
Sure.
Oh, yeah, you can, right?
Oh, yeah.
So you're going over how to get it from GitHub?
Huh?
Are you going over how to get it on GitHub?
If you press, does anyone else need have to need the lesson or get from GitHub? So when you get it from Mac, press sync, and then if you press sync, you should see the top left button not being good anymore. And press that one. Sync up to GA students. I will apply in a second. So, okay. Okay, so.
So I think they all these changes. Like,
Yes, we're going to save that.
Good. So if we open, so it's synced, right? So if we open this in Finder, we should see lessons and lesson 3 and playgrounds. So from there, you copy that to password, and then we just categorize by
So that was.
So basically what I did was, so I pressed sync.
Yeah, that's the bullet from.
So sync your current changes on your local repo to your fork version.
Okay.
And then it also notified for Mac that there was additional changes that pushed to the main repo. And after, so if there are additional changes, then this thing will be able to do it anymore. So always the flow is make your changes, commit, sync, and then update here at the same time. Yeah, so right click here.
oh, I see. So now I have to open the other one.
normal time, yeah.
Okay.
Yes.
So basically,
So this is my
well,
last
this is basically the option folder.
So, I think I was 7 months back. You can ask me.
Last thing off in there. Okay. Okay. I feel like I'm
Yeah, that's it.
I can get the program.
Yeah, it's fine. Good enough is, it is the trickiest part, it's funny.
So this is my,
Guys, feel free to take a break throughout this whole working process. Yeah.
so, this was just, it was updated and synced.
Yep.
And so now I need to open this and make my own version.
Yeah, so don't,
Don't open it.
so I would copy this from NC
Okay.
and then go into your classwork folder. And then lesson 3. I'll see you already have it there.
That's mine.
Yeah, so just open your version.
Oh, okay. The one I was just working on, this is like my,
So this one,
all notes.
yeah, so the other one is one with them there.
Okay, use this
Yeah.
one. Thank you.
Sure. Stop where you'll figure it out.
Yeah. I don't know quite how.
Okay, I think you're right to this one more time.
You were right.
Then I'll post the video of this.
That wasn't right.
Sure. No, I appreciate it. I appreciate
So
the
the
help.
flow is always whenever you have changes, you can read your changes.
Are you cranking out the assignment already?
And then you sync. And then if there are new changes that you sync, this changes your local one to your form repo. And this does two things. A, it pushes your local changes to your repo. And B, it changes if
No.
there are any more changes
Yeah.
on the best.
When it's a real
If
thing.
there are,
It's really good for like, say, I was thinking like a show run.
if there are,
Top.
this button over here will not be
Okay.
will be so sync.
Yeah.
From J4 1 to 100.
Okay. Oh, I see.
Start.
Yeah, and it's just it's you know you have to keep it
Yeah,
down.
the last one.
Yeah, it'll be
I'd walk in and it stops moving. Like after you find it. So let's say you have look at everybody.
Yeah.
It's hard.
Okay. Okay, I see. I see. Got it.
It's a lot easier to break things out.
you doing?
Later, can we go over something? I'm doing fine on everything. Like I just want to understand certain things like how this is working. Like I see history.
Yeah.
And so I mean, now I'm seeing this. I don't know what I'm looking at here. How do I know like what files were changed, added?
Sure. So, first of all, some new changes here.
I didn't say it or anything.
Xcode says it automatically. So,
Sorry, yeah, okay, so we committed.
yep. Next step is sync it to your fork, right? So we go.
Okay, that's alright.
It looks you
And then if there are new changes, this is two things.
Yeah.
A, it syncs it from the local to your fork.
Okay.
And B, it sees if there's any new updates
It's
to
hard to switch.
the master ultimately from your last sync to your fork.
You made your name.
And if there are,
Why don't you see this? Your name.
I think that should be.
yeah. You can just pick that right away.
That should be.
So let's see.
Get to work playground.
Okay, so they say, I'm not sure why this
Well,
thing.
I did this like earlier.
So as far as looking at documents that are saved, just say the file name in the company history, so you can scroll down. The green parts are stuff embedded, right at the middle, but the file is files are this.
Right. So there's no real like clean way to view these files were changed.
There is a GitHub if you go.
So you have to go directly. So basically the GitHub for Mac is really just more for pushing and pulling.
Exactly.
And that's it. And GitHub is what I would use to, okay, so now let's go to GitHub for a second.
Sure.
Yeah, which one? Yep.
Okay, so we're
we're
here, we're going here, and we'll look at the command. Okay, so now here's what's right. So it's like password. Okay, so I see the same thing now. Like these were the files. Like I just want to look at just the files and not like because it's going to take me forever to go to scroll through there. I understand what that hexadecimal value is.
This is
like
This is like the reference point for
Yeah.
certain change. So,
So what happens?
command line is the reference code here. Now, here. Now it's just a command line.
So you know what, I'll just learn from your line and I'll just do it that way.
Okay.
That's what this is.
Yeah. Yeah, okay, I'll probably do a workshop on command line and get sent out in the next couple of weeks, so.
So it's not print, like it's not printed at all here. Like I tried doing it 2 different ways. I tried doing our.
Because the back slash comes before the parentheses.
Oh, so what that was like breaking everything?
Yeah. It's in the page.
Yeah.
Bar age equals whatever. Yeah, that was breaking everything. So the one downside of playgrounds is if one piece of code, one line breaks, it breaks everything else
Oh yeah.
from running in playgrounds. Yeah. It's good and bad, you can't miss any errors, right?
Yeah, attention to detail is like.
Yeah.
Yeah, no choice.
It becomes second nature though. I mean, it's better that, again, it's better for it to tell you and yell at you than just find out, you know, and spend hours and hours. And trust me, that takes hours sometimes to figure out what's wrong.
What's wrong with this one? Oh goodness. Did not hint.
Seems fine.
Why didn't it print 19 here? And it's missing an edge.
Oh.
Oh.
Okay. Just take a second.
Oh, wow. Okay. Thanks.
Sure.
Oh yeah. Correct.
This is a bit easier than plus.
Where that music sitting?
Yeah, exactly. Yeah, this compiler is like years ahead of C++ compilers back in the day.
You ever code, you just hit the text editor?
So for web stuff, I usually just use text editors, but anything that's compiled, like Java or C++ or Swift, I always use the because it gets better.
In your in this thing, with you want us to use count elements, but everything that I'm using is like not good for that. The only one I could get was this one. I can't get this. Is it like we're not importing something? You like it or something? I didn't even see count elements in the Swift docs.
Let me check that.
Sweet.
What did it do?
As you see, it looks like it's removed in the as of iOS 8.3.
Huh.
So it's not a big deal that we use a different function.
No, it's not, but I should probably define what the function is. Okay, so guys, there's one of the questions over here which asks to use count elements. That one does not work apparently as of iOS 8.4. So the alternative is to do, if I have var name equals Teddy, I can do name.characters.count to get the number of characters. Characters, if I spelled it right would help. But again, Google is your friend.
So I copied and pasted. Does this seem like it was the same to me with just different text? So I just copied it and pasted it here, but it's still saying the old.
It's just slow. Yeah, guys, playgrounds. If it's grayed out, the outcome, it means it's still thinking. If it's like excruciatingly slow, just restart Xcode. Yep. Again, you will see throughout the duration of the class that Xcode, although it's our friend and helped us out, it will be also the biggest pain in the ass sometimes. Like I've literally spent before, like over an hour trying to figure something out, only to figure out that like it was an Xcode like memory leak or something.
How can we test in Swift if a certain variable is a certain type that we want? Like, how can I test in Swift that is this variable an integer?
So there's a function, you change those to point on, you check what that is. But there is a function that lets you check the base class of something. I don't remember what it is now. I'll Google it. But Anybody get the Fibonacci one yet?
What?
Anybody get the Fibonacci one yet? We'll get to the point, either by the end of the week or next Monday, where we will be able to Fibonacci sequence problem in like 3 lines of code. Oh, and please don't let me forget before class is over to talk about Thanksgiving holiday options. Oh, that's it. Oh, this was okay. Oh, yeah. Thanks, good problems. By the way, this FizzBuzz problem is like the very first rudimentary programming problem that a lot of interview places give you. And you'd be surprised like how many people like can talk their way through problems or like can talk like, you know, can bullshit their way through theory. But then when it comes to like even simple things like this, which really took us one day to learn, fail. I've had like junior programmers fail the FizzBuzz test, which to me is just like, I can't comprehend how you go for a programming job and not be able to pass the FizzBuzz test.
Is that your first step in like the coding test?
If it's a junior programmer or intern, yeah, more or less. Like if someone can't solve that in like a minute, there's a big red flag there.
Yeah, it's basically like the same thing for each language. Like you can make it fancier,
Yeah.
but you can solve it really.
Yeah. Yeah.
We've had in class we had to do it in like 3 different languages we didn't know.
Yeah. Yeah. It's like one of the most rudimentary problems programming. And the question is, can you do it in one line?
You didn't know lines.
Huh?
Are we supposed to, once we finish this in-class activity, we upload it? We put it to the thing?
Yeah, upload your report.
So, I need help with
Yeah.
the,
We got you.
yeah, I don't understand. Oh, I mean history, okay, I think I know.
Okay, yeah,
That was
yeah.
a stupid question, okay.
First.
So when do you grade this stuff?
I'm usually gonna go for getting it on Tuesday, so we have it for class on Wednesday. Questions. That's the ideal scenario. If not, by Wednesday, then by Thursday.
I couldn't really figure out how to use count elements. I couldn't figure out how to use the count elements. So,
Oh, so yeah, the one was deprecated. So the way you go about it is you do a string dot characters.
okay,
I kind of wish.
so
So this is an operation, right? So because it's an operation in the string, we have to.
also.
I'm just saying, I wanted a bit outside the scope, I made like a function and stuff.
Nice. Let's turn the picture. Very nice. Perfect. And we're doing this in class. So, great. Yeah, it's looking really good. Nicely done.
Oh, by the way, I found that there's this, so this shows you.
All the history, okay, so then moving on there. Okay, cool.
Also,
You know what? On the Zoom, yes, accessibility.
Do you know what this is? These first three lines.
It shouldn't be giving you an error. Try and call it that. Yeah, it's a, so it looks like it's an environment. It's called an Xcode. I have no idea.
So would something like this affect like my code if like this was not in the playground and this was in the,
It shouldn't. It shouldn't. It's playground is weird because it's like sandbox where you can actually change the like, a lot of environment settings. So this should not affect.
I'll just go Google that and see what that
Okay.
is.
Yeah, you can find a little stream message and look at it.
So your Fibonacci lines is you're doing this function in 3 lines. You have a more.
So the Fibonacci, I think I got mine through 3. Yeah, it goes through lines. Yeah. You use ternary operators, where you can check it and run it in. Entering operator, have you worked with those yet?
I've heard of them. That's like where you say, print X is equal to like question mark less than 3, then semicolon.
Exactly.
Variable.
Yeah. So do something if this value is true, and the first operator is wrong. And then if the first operator is a question mark, it also right. That's in our class in the PDF class notes. So I think the reason it's not working is because of random.
Basically just need to file.
Oh, I would just do it in here.
Kind of blew me because like that's where my notes were.
Yes, the random is. So there's a way to convert into digits. It's really cool. We'll spend a couple more minutes on this and then we'll go over the answers. Yeah.
Can I say this like while x is less than 50 times 7?
Yep.
And then for this I was doing x. Oh, wait, wait. Yeah, okay. And then x plus 7.
So x plus 7 adds x plus 7, but it doesn't set the value of x to be x plus 7. So if we're not set x to be x plus 7.
Oh, x equals x plus 7. Ah, okay. Ah, yes. That didn't work. It just didn't stop counting, but it didn't work. I'll see if I can figure it out.
All right, 1 second.
Copy all this.
Yeah.
Because when Xcode, I can save it.
Okay.
So
It should save it automatically.
it didn't save it a couple of times. When it crashed, when I first played
Oh.
You didn't save everything.
Okay.
It's fine. But I had everything because you were recording.
Good. I'll push solutions up in a second here. So we did this one, that one. Cool. Anybody want to help me out with these and take a stab? So let's go ahead and go over these collectively. I'll post answers as well tonight. So who wants to do this one over here? I think the rest of them are pretty straightforward. We already did the driving one and the drinking one. Anyone want to come up and do this one? Yeah. Okay.
Still don't understand what it means by 7 minus 1. See, that means 6.
Mhm.
One the first.
Well,
Because
so
it'd be 6, 12.
yeah, so it's a bit of play on words, so you can kind of think through the. So first of all, let this one move here.
Oh, sorry.
Or you can do this first. 7 minus 1, right? You can think that you can set variables to be the result of mathematical operation. That's what kind of you think. So, wait a second. I'm losing myself here. What was I asking? What's the model of 7 minus 1?
So the first one would print 6, and then it would add.
Yeah, so we're asking for 2 things. Number one is the first 50 multiples of 7 minus 1, which is 6, right? And then the multiples, and then multiples of 7. So we're counting from 1 to 50, and then we're saying, I realize I'm not word this very well. That's right, actually, yeah, so 7 minus 1, yeah, that's exactly right. Okay, I had to get back in there. Okay.
So is this like a better way to write it than the while way? I mean, multiplication?
What would be the wild way of doing it?
That's the one I was showing you. Like, so bar x equals 0, while x is less than, quote, parentheses 50 times 7,
Mhm.
and then print x minus 1,
Mhm.
and then x equals x plus 7.
So wait, you're printing x minus 1?
Printing x minus 1, yeah.
Do you want to show us your version?
Sure. Can I take this with me?
Sure.
Okay. Sorry, I just don't want to print.
while we practice. Yep. Cool. Yeah, so the difference here is Santiago initially started with a 6, right? Whereas Javier is always going with a 7 and subtracting the 1. So there's, anyone do it differently? Yeah.
Well, this might not be all the way right. Sorry. So for yeah, timed out. Oh. Yeah, but yeah, I did like that.
That's interesting. Okay. All right.
It's just iterated from there, I guess.
Yeah. Okay. I realized I don't ask the question very well there. It took me a second to even remember what I was asking. I think these ones are pretty straightforward, right? Everybody else was able to find the string of characters to count instead of the count elements. Was anybody able to figure this one out? No.
So put this all of 100 random numbers.
Do you want to show us them?
Yeah, sure. Just in case.
So this one you can do the Googling part.
Oh yeah. Since we're doing ref, and then I say final num is equal to final num plus int.
So this part is the Googling part.
What?
This part is the Googling part. So can you explain what this int here is?
I'm typecasting it because it's giving me an int32, whatever that is. I'm guessing a 32-bit int integer. Versus whatever a regular integer is, and so I'm converting it from a 32-bit int from an int32 to an int, so that you can do the addition. Otherwise, it's going to give you an error.
So yeah, random gives you an int32 by default.
Random, not random.
Oh, random. Sorry, random is int32. Random Question I remember. But random takes a few parameters by default. We have to tell it a kind of the size of the integer, and then another value in there of how we're generating the random. So the rand is a bit more out of the box. But I think by default the random might return the integer. Yeah, that's nicely done. Yeah, so basically rand, but you have to do Google for this. Rand gives integer 2, right? So I know some of us were struggling and we're trying to match this up. So you're setting the final num be an int32 to 0, which actually I love because you were going down the right path. But what this int here is doing is it's setting the int32 to be an integer. So it equalizes, so it's the same type as our initial 0 over here. Does that make sense? The same concept as you can't add an int and a string, right? You can add an int and an int32. So we're going to run across this quite a few times in the future because there's a bunch of different integer types we're going to be working with. So this is called typecasting. And typecasting is essentially setting a certain data type to another data type.
Could that have worked if you skip the first line of that block and just typecast to the rand function directly? I think you could like.
You can do that, yeah. Smart. Cool. Anybody get the Fibonacci? You want to show us more time yet?
Sure. Yeah.
So we'll go over the shorter version for this next class. This is getting ahead on class.
Are there any limitations on rand? Like, the biggest number it could be
Yeah, you can set parameters.
used
Yeah.
by default.
By default, I don't know what it goes up to. Yeah, and you can go and check under limitation, but it goes up to the millions. It just doesn't know how high.
I kind of want to do my function thing because now I'm like thrown off a bit. Okay.
Use Google to define things, not to find the full answer. And one thing I also want to note, we'll keep stuffing this up and we'll explain what's going on. It's okay to Google stuff, and a lot of times to get answers from Google, as long as you don't copy paste. If you're gonna copy something verbatim and plagiarize, type it out. At least type it out so it goes in your memory. I don't again encourage copying everything verbatim and understanding things, but if you do copy things, if you do understand it, type it out. Always type it out.
Just push OK here.
Yeah. I think it's having trouble compiling for this.
I think that works. It's this goes up to, it goes from 230. I want to go 37. And that should be it.
Where did you find some of them?
Up here.
Ah, okay.
Okay, so I think that is the answer that I got. Yeah, I mean, I'm assuming that's right, but I could be wrong. So the final number is the first two numbers added together, and then I just make the first number, the second number, the second number, the last number.
Yeah.
Yeah,
so Fibonacci sequence is basically, that's exactly right. It's about temporarily remembering your place and storing where it's done. It's about remembering your last first number and your last second number. So remembering your place and then adding those as you're counting them. So just a matter of placeholding, right? So when we go to functions, we can condense this even more. And then when we get ternary operators and a bunch of different operators, we can really do this in just a couple lines. It won't be pretty if we did two lines. So that's the goal.
The one thing that I know that this logic is technically right. The one thing that I always find myself stumbling on is the fact that the first number is 0, the second number is 1. Okay, so I set the first two initial numbers, but then I did a loop and I started it at 2. And you wanted the 37th Fibonacci number. So if you want the 37th Fibonacci number,
You're technically at the 35th, yeah.
I'm at the 35th, so I want to start at 0 instead of 2.
Yeah.
Okay.
So why did you not have 0 there? Was it?
I kind of thought that since the first one is 0 and the second one is 1.
I would start at 1, not at 0. So I would start at 1, and because the first number is 0, right?
Because when I'm starting at 2, 0, 1. No, if I'm starting at 2, I'm getting the third Fibonacci number. The third Fibonacci number is 0, 1. The third Fibonacci number is 1, right?
0,
0,
1, 1, 2. 3, yep. 0, 1, 1, 3. So so we're starting at 0. So this is really like the fourth Fibonacci number. So if we go from 0, 1, 1,
That would be
2. So why is it yelling at us? Interesting. That's weird. Final num, this one. First num. So final num is first num plus second number. 1, first num. Second number. I can only figure out what's going on with this offline plus an answer. This looks right because we're storing both of those temporarily.
So since we already have the first two numbers, we want to start on the third number. The third, if we start on.
Oh, because we're not doing a function, because this is running as a loop. So as a loop from 1 to 3. 0, 1, 1, 3, 2. So we need to set the second number baseline right now, or the final number baseline should be a 0, right? Because we don't have a final number yet, right? And then we also don't have a second number yet. So we need a counter. Numbers.
I don't have this.
This is the world of debugging, guys. They're gone. Yeah, I'll have to look at this offline. I don't want to waste any more time here. I'll post their explanation for this on Slack. Huh?
So if you do them in 3 lines of code, you need to know about
You know functions. So we'll go over functions next class, and we'll do that.
Okay.
Okay, so quick logistical thing. We need to figure out our Thanksgiving plan. We have class, or we're set to have class the Wednesday before Thanksgiving. We have 2 options. Actually, 3 options originally. The third option is an option more because I don't want to break up the class, so we have the last day of class after break. That's silly. So option number 1 is we have class the Wednesday before Thanksgiving. Option number 2 is we have to do a makeup class either during the week or during the weekend, sometime between now and actually it's to be pretty soon because we have to fall within the same cycle of Monday, Wednesday, right? Otherwise, our homework cycle will be shorter, right? We only have a couple days to do homework. So does anyone have a preference on whether we do Wednesday or whether we do a makeup class? Wednesday? Makeup class? Okay. Did you say it's too early? Okay. Maybe I'll do pulse check then in a couple weeks. Regardless, it'll be recorded, so.
Live.
Live.
Teddy cam.
Scary.
Said there would be so much.
Cool. So we covered quite a bit of ground today. Any questions on loops, conditionals, data types? Yeah.
I'm getting a little shaky with this stuff.
So A, I'll post solutions to all these. And B, so for homework, there's the mobile Git book. There's pretty thorough explanations we've done for all of these. So if you load up your lessons from GitHub, there's links to more thorough explanations to all these. And then the mobile Git book also has links to the Apple tools and other resources. And then if you're still shaky from there, I'll go through the resources. There's one book I'm looking for in my library, which is not necessarily the nitty-gritty kind of syntax kind of things that we get here, but it's kind of like theory of breaking things down, kind of rudimentary introduction. If you've been doing programming for a while, you might not need that, but if you're just getting started with programming, it might be helpful to kind of the logic of structuring your code and breaking down your logic. So I think that will come really useful in the next couple of weeks. So I'll look for that one and post it in Slack. But the most important one as of right now is to read this literature on the mobile Git book because that points to the developer documentation as well on the Apple side. And then, sorry, one more logistical thing. I'm going to be doing office hours on Tuesdays at 5:30. Is that a problem for anybody?
5:30 to when?
5:30 to 7, usually. And then I'm always online on Google Hangouts, like literally always. Yeah.
And in person. It's impossible.
Okay, so we can do Hangouts. Yeah. Another option is if you let me know a few days ahead, I can also come to class earlier. It's literally around the corner. So.
Our last class for this class is the 16th.
21st.
21st. So we lose one day, or we have?
No, we have a makeup day.
We have a makeup day. We're gonna have a makeup day if we don't do Wednesday.
So we come back from like winter break and then all of a sudden we just have one class.
Is it final? Yeah.
I mean, oh, I see.
Yeah, I mean, that would be horrible if it's a final.
I would miss the 21st.
Okay. Well, the last day before the final is work on final project day. So yeah, we play by ear. I can poll you guys again in a couple of weeks. Let's see where we are. Cool. Exit tickets, please. I'll post the link right here.
Thank you.
See you Wednesday.
Thank you.
Thank you, guys.
Well, actually, I'll see you tomorrow.
That's right. I'll be here. So I'll be here tomorrow at 5:30 if anyone needs office hours. And if you just hit me up, I'll be on Hangout.
During that time.
Anytime really. We'll just set a time. It's fine.
Tuesday's a little rough for me too, but I'll work with you.
Yeah.
Oh, really?
Tuesday night.